This example, we're now going to get to the real deal. Now we're going to do what we're supposed to do. This is everything we have been studying leads us to this, to determine resultants, okay, of two or more forces. So this exercise says determine the resultant of the following forces by the component method of vector addition, which is what you're going to be doing using trigonometry. So here you have three vectors. In our diagram, we're going to be using the components of these, the scalar components. So we're going to omit. Notice that in this case they are in bold. That means they are vectors. Remember that when we type them, we actually use we say A with an arrow on top, B with an arrow on top, C with an arrow on top. But when we're doing this analytic, we're going to omit the arrow. We're just going to assume that we're dealing with the magnitude. So why don't we go to a Cartesian plane? That always helps. And we put these angles right there, just so we know it. I'm going to omit rulers right now for the sake of time and load of this video. So the first one is 200 newtons at 30 degrees. So when I go to my Cartesian plane, I'm going to estimate that bad estimate. Sorry about that. Let's say this is 30 degrees. Okay, so this is the reference angle of A is 30 degrees. This is my vector A. Okay, and I'm gonna go back, and the other vector is B, 300 newtons at 330 degrees. So I'm going to go back, and this is 90, 180, 270, and 330 is going to be somewhat like 30 degrees before getting to 360. So I'm going to say it's, I'm sorry about that. Let me fix that. I'm going to say it's some, you know what, I'm going to use the arrows. I think that's going to be a lot better. So let me use this. And I'm going to say that this vector is approximately here. It's 300 degrees, so it's like one time longer. Or this is two times, and this is 200, and this is 300, so that's going to be approximate length of this one. I'm going to redraw this one, and I'm going to well, I'm going to leave it like that. And this vector is going to be called vector B. Vector B. And here we have the reference angle for vector B. Okay, and this is called vector B. Vector A, let me write the magnitude right there. Vector A has a magnitude of 200 newtons. And vector B has a magnitude of 300 newtons. Again, at 330 degrees, but the reference angle is 30 degrees. Okay, just like this one. So our next vector is 400 newtons at 250 degrees. So let's draw that vector as 400 newtons at 250 degrees. We go back to a Cartesian plane. Here we have 90, 180, 250 must be 20 degrees before getting to 270, and that is a 400 vector. So it should be somewhere in here, and it's 400. It has to be a lot longer than this one because this is 300, 200. This should be twice this one. That, of course, you're going to estimate it. So this is vector, I'm going to put it with black. This is vector C, and vector C has a magnitude of 400 newtons. Now, the reference angle is right here from the x-positive. Remember that? The reference angle for vector C is going to be, remember, this is 90, 180, and it's 250. 250 minus 180 is going to be equal to 70 degrees. So that is a reference angle for vector C. So the first thing we're going to do is we're going to get the components for each vector. So that's what we're going to do right now. Of course, you don't need to draw it. You can do all this analytically. I'm doing this for the sake of clarity. So here's a component in A for the component in X for A, and here we have the component in Y. Now you already know that the component in X is going to be equal to A cosine of the reference angle. The component in Y is going to be equal to A times the sine of the reference angle. So we can substitute. What is the magnitude of A? The magnitude of A is 200 newtons. Is it positive? Yes, it is positive because it's pointing towards a positive x. And the angle, the cosine, the reference angle, we determine is equal to 30 degrees. And for y, we notice that the component in y is also positive. So we write the magnitude A and write the sine of 30 degrees. So you grab your calculator, make sure your calculator is in degrees. So I'm going to do that right now. We start with the first one. You type 200 cosine of 30 degrees. That is going to be equal to 173.2. You're allowed to use 3 significant digits, but it's not a final answer. Therefore, we underline this one and we write an extra significant digit. Make sure your calculator is in degrees, please. Otherwise, you're going to get a different answer. So you have 200 sine of 30 degrees. That is equal to 100 newtons. Remember, you must have 3 significant digits, so you might want to put a point in here to indicate those 3 significant digits. So then we have the components for A. We have component in X and the component in Y. Now let's go to vector B, which is this one right here. And let's get the components for vector B. The components for vector B are going to be, we have this one right here, and we have this one in here. Applying the same formula, there you go. Applying the same formula, we're going to say that we have bx and the component of b and y. Now for a horizontal component, we're going to have b cosine of alpha, the reference angle for b, and this is b sine of the reference angle. Now notice the component in x is positive, so we just leave it like that, but the component in y is pointing downwards, so it's negative, so we're going to add a negative sign in here. So we substitute values, and the magnitude of vector B is 300 newtons. Then we have the cosine of a reference angle, in this case it's 30 degrees, and this one is negative 300 newtons, and the sine of 30 degrees. So you grab your calculator and you write 300 cosine of 30 degrees. That is equal to 259.8 newtons. And for the other one, 300 sine of 30 degrees is equal to 150. But this is negative 150. We add a point to indicate 3 significant digits. So then we have the value of the components of B. It means that this vector has a magnitude of 259.8 newtons, and this one down here has a magnitude of 150 newtons. Now let's get the components of vector C. The components of vector C are, down here, it's all the way down here. There's a component in Y down here. Okay? And we have the component in X, which is approximately here. So mathematically, we're going to get each component. We get Cx and Cy, and the component of C in X again is C cosine of the reference angle C and C sine of reference angle C. Now notice the X component is towards the X negative, so this component is negative, and the Y is also pointing downwards, so both components are going to be negative. So we substitute the values, and we have that, well, the negative sign here, 400 newtons cosine of 70 degrees. And here we have negative 400 newtons sine of 70 degrees. So you operate the calculator, you're going to get 400 cosine of 70 degrees. That is equal to negative 136.8 newtons. Underline this. And here we're going to get 400 sine of 70 degrees. That is 375.8 newtons. Notice that after 8 you have a 7, but since it's not a significant digit, you do not round it. Okay, so so this is how you do it. Now notice that now we have all the components in x for a, b, and c, and we have all the components in y for a, b, and c also. Now I want you to pay attention to these vectors over here. We have this is a component in x for a is right here. You don't see it because it's covered by vector, by the blue vector. Let's see if I can bring it out for you. This is the component in x of vector b. This is a component in a of vector a. I'm sorry, the component in x of vector a, the red one you see right here, and this black one is the component in x for c. So notice that these vectors are collinear, so we can add them. We can say this plus this one. Now these two are positive, this one is negative, in such a way that we have the following. We have that the component I'm sorry, since we're getting the resultant, what we're trying to get here, this thing decides to work, what we're trying to get here is this vector, the vector a plus b plus c. Okay, now for the sake of space, we're going to call this one a vector r. We're going to call this the resultant. So we have that r, since this is a vector, r must have a component in x. This is the resultant, the sum of these three vectors. And this resultant must also have a component in y. Now, what is rx going to be? The magnitude of rx is going to be the sum of ax plus bx plus cx. And notice that in y, we also have three vectors. We have this vector, which is a component of a in y. We have the black one, which is a component of c in y. And we have the blue one, which is a component of b in y. So what I'm going to do right now is I'm going to move this a little bit. I hope I can do it. I'm going to just delete this and I'm going to rewrite it. We need to get a component of r in y, which is equal to ay plus by plus cy. Okay? Now, so when we add them, what is ax? Well, ax is 173.2 newtons. Plus bx, we already computed it, is 259.8 newtons, plus the component in x for c is negative 136.8 newtons. So when you add all that, grab your calculator, please notice a negative sign. We have 173.2 plus 259.8 plus negative 136.8. We're going to get a final value of 296.2 newtons. So the resultant has a component in x equal to 296.2 newtons. Now let's go to the component in y and see what we get. The component in y for a is 100 newtons, 100 point newtons, plus by, which is negative 150 point newtons. And the component of c in y is negative 375.8 newtons. So when we add all this, we should get 100 plus negative 150 plus negative 375.8. We get a value of negative 425.8 newtons. So here we have a resultant. This resultant has a component in x and it also has a component in y. So I'm going to pick a color. I'm going to pick green to try to represent that vector, those two vectors. So 296.2 newtons. Now the question is, in what quadrant is it? How are you going to determine what quadrant is this vector? Is it in here or is it in here? Since a component is positive, then it means that it starts and it goes towards the x positive. So we're going to say this green one, maybe I'll make it thicker so that it sticks out from the rest. See if I can do this. Oops, make it very thick. Oh, not too thick. I think that'll work. Okay, so here's a component of the resultant in x, is this green vector over here. And the component in y is negative. It means that in y is traveling downward. So I'm going to represent this one, and it's very long because it's 425. I'm going to make it as long as I can. Unfortunately, I cannot go any further. So these two vectors are the components of my resultant. It means that my resultant is here in this quadrant. Now, how am I going to get the magnitude of that resultant? Because I need to get the magnitude of r. To get the magnitude of r, sorry, I'm going to use a black ink. To get the magnitude of r, I'm going to use a Pythagorean theorem by saying that r is equal to, because if you notice, when I have this vector and when I have this vector, if I draw a line over here, or if I were to get the sum of these to represent it in here, my resultant, or this vector, whatever it is going to be the hypotenuse of a right triangle. So I'm going to use a Pythagorean theorem to get that magnitude. And this is a procedure you're going to be using all the time, every time you're getting components. So the component of r in x, we said, is 296.2 newtons, close parenthesis, squared, plus the component in y, which is negative 425.8 newtons, that's squared, and you grab your calculator and you write 296.2 squared plus negative 425.8. Now you gotta be careful when you write the negative. If you're gonna write the negative sign, then write parentheses and make sure in your calculator you write the square outside. If you do not include parentheses, or if you include a negative sign but write this 2 inside, the number is gonna deliver you a different answer. So if you're gonna use a negative number, make sure you use parentheses and write the square outside the parentheses in your calculator. So you're gonna get, oh, and don't forget to get the square root, please. So the magnitude of this vector is 518.6 newtons. Okay, that's the magnitude of our resultant. But the question is, what is the angle of the, what is the direction of this vector? Because this is a vector, we need direction. How are we going to get that direction? So what we're going to do is, we're going to use a inverse tangent. Why the inverse tangent? Let's see if I can help you visualize that. I'm going to draw, okay, now I have this line here. If I were to draw a line in here and in here, we'll notice that this is the opposite side, or this is the adjacent side to my triangle, and this vector is the opposite side to it. So which function relates the opposite and adjacent side? Exactly, the tangent. So we're going to say that the tangent of my reference angle, because I'm going to get the reference angle, is going to be equal to the opposite side. Now, if this is the reference angle in here, this is the opposite side, which is the y component. So it's equal to ry divided by the component in x. Now let me continue over here because I don't have any more space. So my reference angle then is going to be equal to the inverse tangent of my component in y. Sorry about that. My component in y divided by component in x, and I'm going to do absolute value for that. So my reference angle is going to be the inverse tangent of my component in y, which is this one over here, negative 425.8 newtons, divided by 296.2 newtons. Make sure your calculator is in degrees, please, otherwise you're going to get a different answer. I'm going to delete, oops, no, I didn't want to delete the whole thing. There you go. So I'm going to, this little thing over here, so that you don't get confused with, and I'm going to write it again as an inverse tangent. So you're going to divide, my advice to you is divide 425.8 divided by 296.2, and then you get the inverse tangent of that, and you're going to get a reference angle equals to 55.17 degrees. We're going to use 3 significant digits for the angle. It means that this vector, I'm going to make an estimate, has a reference angle of approximately 55.17. So it means that probably my vector resultant is somewhere in here. Okay, somewhere in there I have my vector angle. Okay, so this vector is the sum of A plus B plus C. So how are you going to state this? I'm going to go back. Remember, the magnitude is 518.6 newtons. Now this is the reference angle, but the question is, what is the vector angle? Well, if this vector, I'm sorry, if this angle is 55.17, we're going to leave it at 15 degrees for the sake of clarity. 55, I'm sorry. So we're going to say this is 55 degrees. That is our reference angle. Now what you're going to do to get the vector angle, here you have 90, 180, 270, 360. But to this 360, you're going to subtract 55. So to get the vector angle, you're going to subtract 360 degrees minus 55 degrees. That is going to be equal to 305 degrees. So your final answer, which I'm going to write right here, we're going to say that A plus B plus C is equal to, let's go back, 519 newtons. 519 newtons at, and we're going to say 305 degrees.